Hey guys, in this video, I'm going to teach you how to find a confidence interval for the linear regression. So, before I do that, I need to explain to you or remind you what this box is over here. Okay, so let's read it really quickly. It says, as part of a class project at a large university, Amber selected a random sample of 12 students in her major field of study. You should stop right there, and the first thing that you should do is say to yourself that the degrees of freedom is always n minus 2, and in this case, it's 12 minus 2, which is 10. So that's going to be really, really important, okay? So the next thing is, it says all students in the sample were asked to report their number of hours spent studying for the final exam and their score on the final exam. So here's the regression analysis from a computer. So I'm going to do yellow for y-intercept, and I will do light blue for slope. Everything that's yellow belongs to the y-intercept. Everything that's blue belongs to the slope. And it's always that case, okay? And how do we know that? Well, this word here is constant, right? And constant refers to the y-intercept. This here says study hours, but in many cases, in all cases, it changes depending on the problem. So in this case, study hours is our x variable. In the next example, lead will be replaced. Instead of study hours, it would say lead, and lead will be our x, and so on. So that variable changes, but constant always stays the same. So first, you should say to yourself, I'm never going to use any of these numbers on top in the yellow. The only thing that you get from the top line is the y-intercept's coefficient, which is 62.328. And the reason behind that really is because the y-intercept in many cases is meaningless. Sometimes when you plug in x to be 0, it gives you a y-intercept that really doesn't interpret to anything that means anything. So that's why we don't really care about it. Okay, so how do I write this equation of the line? So I'm going to take the y-intercept, which is 62.328. I'm going to take the slope, which is 2.697, and I'm going to take the variable right next to it called study hour. But we know it's an equation, so it has to equal something. If you take a look at the problem, the y-intercept is the y hat you have to get from the problem. So it says here, hours spent studying for the final exam and their score on the final exam. So this guy here will be final exam score, okay? So that is how you get the line of best fit using a computer output. So that's wonderful. We're done there. So basically all you need is this. So I always tell my students to make sure that you draw a boot. The boot is really important. It grabs this guy, the toes. All right, so let's begin our, well, actually, one last thing. This guy here is the y-intercept. This guy here is the slope. Other than using to create the line, the y-intercept, the whole line is gone. Okay, so just cross off this whole line. So you only have these two values here, 2.697 and 0.745. If you see above 0.745, it says SE. SE stands for standard error. Standard error means that they already took the n, or the square root of n, and divided it by the s. So it's all in one, okay? So you don't have to do anything else. So if you recall our confidence interval, in averages, it would be sigma over the square root of n, or s over the square root of n. And if you remember from proportions, it was p hat q hat over n, all square rooted. In this case, this is the entire answer. This is the standard error, or the standard deviation of the coefficient. So let's discuss the confidence interval for this. All right. Constructing a confidence interval for the slope. Step 1 is our conditions. There's 3 conditions that we should have. First, the scatter plot has to be somewhat linear. So that should make sense. If you end up getting something that looks like this, why would I even bother checking to see if it's linear? So you want it to be somewhat in a linear trend, okay? Or linear, somewhat or linear, okay? Somewhat linear or linear. Next one is going to be the residual plot doesn't show a pattern. If you watched the last video about residuals, I told you that when residual plots show patterns, a nonlinear model should be used. So because we are working with a linear model, or we want to interpret the slope of a linear regression, then we want the residuals to show no pattern. And finally, the data is random, okay? We want to make sure that if you're using, let's say, a father's height to predict a son's height, that you don't want to choose like 2 kids from the same family. So it has to be random, independent. So that's step 1. Those are your conditions. Step 2, statistic plus or minus critical value times the standard error is typically, or is our confidence interval formula. What you want to do in this case is, for statistic, is the sample something. So we have x bar is the sample mean, p hat is the sample proportion. In this case, we want the sample slope, and that is going to be this b right here. Once again, plus or minus critical value, it must be a t, never a z, and n minus 2 degrees of freedom. And we're going to times that by the standard error. Now, this type of problem usually comes with this type of box. So this is your sample slope, okay? And this is your sample, your standard deviation of the sampling distribution, or what we call the standard error, okay? So we put those numbers in here, and then we say, based on this sample, we are 95% confident for every 1x, the y increases on average between blank and blank. So in the first video, I taught you how to interpret the slope. And basically, when we go to interpret the slope, we say for every 1x, the y increases or decreases by a specific 1 unit, okay? So some unit. Now what we're saying is for every 1x, it's going to increase or decrease, okay? Or decrease between this number and this number, okay? So let's pretend that we did this problem and we try to find the confidence interval for it. So let me grab the big eraser and just get rid of all this stuff here. And I'm gonna do another video on this, but this is basically just to teach you how to do it. And then the next videos will just be example after example. So what I always tell my students to do is between these two guys, I put a plus and a minus. So we have b plus or minus tc n minus 2 times se. And obviously we don't care if you multiply tc n minus 2 times se or in reverse, because multiplication is commutative. So 2.697 plus or minus, I'll leave this guy out here, 0.745. And what I need to do is I need to say there were 12 students, and because there's and we want 95%, so you would have to find 10 degrees of freedom and the t-value for that. And that t-value is going to be 2.228. So in this problem, they just asked you for the margin of error, and the margin of error would be this guy here. Notice these other answers divided by the square root of 12. The standard error already comes with the value being divided by the square root. So that's all we have to do here. Now, just to save time, let's just pretend that the answer ends up being somewhere between number 3, 5. Okay, let's just pretend. The way that we interpret this is we say we are 95% confident that for every 1x, so for every 1 hour someone studies, that their final score will increase between 3 and 5 points. I'm assuming score on the final exam is points, right? So for every 1 hour someone studies, that their grade will increase by 3 to 5 points, okay? But we have to say the word on average. So in the next video, I will show you a problem from start to finish.